Here's a great example of how you have to change the way that you think about questions on the SAT. Because your math brain really likes to read a question and solve the question. Read it and be like, okay, what do they want? I'm going to give them what they want. I'm going to construct the equation and solve it the way they want. And you're very kind of like front to back, forward, front of the question, forward to the end, right? So you're thinking linearly through the question. And we need to do that in math a lot because we don't have answer choices. But on the SAT, when we have multiple choices, we have the ability to reverse this. Especially when questions are confusing and the question isn't really clear about what it wants or it just seems very difficult, we can say, well, let's ask different questions. The answer choices are telling me what to care about. Let's reverse the process. Let's look at the answer choices and use the answer choices to ask different questions that we can hopefully answer more easily. So a lot of times what I call this is narrow your focus, right? Don't try to read and understand every aspect of this story at once. It's confusing. Narrow your focus to what matters. So if we go right to the answer choices and try to work backwards, we see there's a lot here. But right off the bat, some of it doesn't matter. This whole thing at the end where p is less than or equal to 150 doesn't matter. I don't even care about it because it's the same in every single choice. So it's irrelevant. It looks scary. It might be important if I were coming up with this story out of the blue, but I'm not. I'm not coming up with a brand new equation. I have 4 equations here. I'm just seeing which ones matter. So right away, half the question is kind of dead. Now I'm saying, well, what else seems to be different between the choices? And I notice there's a clear break between choices A and B and C and D, right? What are we multiplying this 0.2 by? Is it being multiplied by just 300 by itself or this 300 with some extra? Well, let's go in. What does this 2.2 mean, right? So I see 20% in the question. So if more than 20% of all participants chose the first picture in the set, which of the following inequalities best describes the possible values of P? So it's supposed to be 20% of all the participants, right? I know that 20% corresponds to 0.20 as a decimal. So how many participants are there? Look at the top. In the experiment, 300 people were presented with a set of 5 pictures. So there's 300 participants. So A and B are wrong because they're somehow adding or subtracting to the number of participants. What I want to do is take 20% of 300. I could do it with the calculator, but I don't actually care because that's not the task here. The task is to just sort through these 4 possible equations and see which one works. So all I know is from the instructions in the question, I need to take 20% of 300. And mathematically, that's going to look like this, multiplication. I don't want any extra stuff. 20%, 300. That's all I was told. Now I have another choice, right? Now I have to choose, is it plus 36 or minus 36? Well, what is the 36? Let's go into the question and see. I see it right here. So each person was asked to choose the most appealing picture. Of the first 150 participants, 36 chose the first picture in the set. Among the remaining 150 participants, P people chose the first picture in the set. So there's a correlation here, obviously, between 36 and P. And sure enough, they're next to each other in the equations. If more than 20% of all participants chose the first picture in the set, which of the following inequalities best describes the possible values of P? So here's where I think we can make a pretty safe assumption that if the 150 people, actually let's write it like this. Let's make it really clear. If I have 150 people doing one part of the survey, right, the first half and the second half, to get my total of 300 people, right? This isn't really math formula, but it's kind of the same. Well, of those 150, the first 150, 36 chose the picture. So it would make sense to add in the number, whatever it may be, from the next 150 to get the total who chose that picture, which is kind of what we want. So D is the answer, kind of just because they're in their own weird way asking for a total, and I associate total with plus. That's it. Do I truly understand what's going on here? No. I could think about it more and try to really dissect it and maybe be even more confident in my answer, but narrowing my focus kind of means I don't need to do that. The whole point of narrowing your focus is that you don't want to think about everything at once, because our brains are just not that good, especially into hour 4 of one of these SATs. Like, you're going to be tired. So don't overburden your brain trying to think about all this big picture stuff. Narrow your focus to one thing at a time, and you'll be able to eliminate answers and still get the answer with kind of the most minimal version of understanding possible. This is I would be very confident in this answer, even though I still don't totally understand this question. But that's the benefit of narrow your focus, is you turn off the part of your brain that cares about understanding everything. We do this in the reading section all the time. We're just applying it here to the math, where it's a little rarer, but it's still a valid strategy.